Good morning, dear students. Today is our fifth practical lesson, and it is about application of definite integral. So if we, on previous lesson, were calculating definite integrals just calculated them, and now we will use definite integrals in different physical tasks. So the first of them is to calculate the area of the region that is bounded by different lines. So how to calculate it? Let me remind you. We'll solve task 1a, and here we have a function f from x equals x, and g from x equals 2 minus x squared. First of all, you need to plot a graph of these curves that bound the area, the region, and then you will understand how this region does look like. So here is a parabola intersecting the straight line, and we can see that we need to calculate area of this segment. So in this case, we need to calculate the integral. So area equals so integral from a to b. In this case, g from x minus f from x. So add. So we subtract bottom function from the top. So we subtract the greatest, so a greater function. And how to define bounds of integration? We need to find points where these graphs are intersecting. So here is a point -2, -2, and point 1, 1. And what is required for us only x coordinates. So we calculate integral from -2 to 1. And now let's substitute our functions. So g from x to minus x and minus x. Somebody wants to join. Let me admit. What's going on? Okay, let me stop sharing. It will be easier to. Now everyone is joined. Yeah. So don't forget to join via Google. Via Nureg Google account. So just to save our time. Okay, continuing. So now we can integrate this function. So 2x minus 1 over 3x cube minus 1 over 2x square. And with the substitutions from -2 to 1. And now let's calculate. So here 2 minus 1 over 3 minus 1 over 2. And here if we substitute minus 4 plus 8 over 3 and minus 2. So what do we have here? So 2 plus 2 plus 4, so 8. and here okay, 8 minus 5 because of this. Oh, so 8 minus 3. Sorry. So 1 over 3 minus 8 over 3. So it will be minus 3 and minus 1 over 2. So we have 5 minus 1 over 2 and it will be equal 9 over 2. So positive result, adequate result. And let's also check these materials. Yeah, 9 over 2. Any questions about this exercise?
No.
Okay. Yeah, and B is analogical, we will skip it, but here we integrate by variable y. Yeah, here is a mistake. Mhm. If I can edit it, no, I cannot edit it, unfortunately. But here must be y, and here y as well, because it's easier to integrate by y. So if we were integrating by x, for example, we would have to split this region by two regions. So firstly, find the area of this region, and then find area of this region, and after that add them. But if we integrate by y, so we calculate so from this to this, and it is more convenient, so we have to calculate only one integral instead of two. Okay, any questions about this exercise for now? Okay, if no questions, let's move next. Now we have to calculate the area of the figure bounded by x-axis and the first arc of cycloid. Let me let me plot the graph of cycloid just for better understanding. I guess you know what is cycloid, but let me remind you. So this curve is given in a parametric form. So x equals 2 by t minus sine of t. And y equals 3 by 1 minus cosine of t. And t from 0 to 2p. So first arc of cycloid corresponds values from t from 0 to 2p. So if 1p, 3p, so 2p is always, so if I write, for example, like this, so it how does it look like? So this is cycloid, so a lot of arcs, but the first one is corresponds this values of parameter. So we will have to integrate from 0 to 2p. Now we need, so calculating the integral. So how to find here the value? So as we already know, from 2 to p, and the formula is the following: y from t multiplied by x prime from t dt. Why actually such record? Because dx equals x prime from t dt. So if the function was given explicitly, so that's why it's written in such a form. It will be also important in calculating line integrals. Okay, so now let's calculate x prime. So it equals 2 by 1 minus cosine of t. So y by x prime from t equals 6 by 1 minus cosine of t square. So now let's expand brackets. And yeah, as we can see here, we'll have so we'll have to reduce also the power. So 1 minus 2 cosine of t plus cosine square over t under the integral. Now let's reduce the degree. So so plus 1 over 2 and 1 over 2 cosine over 2t. Also, we will add 1 and 1 over 2. So 3 over 2, moving here. And now we can integrate it. So what we will receive? So 6 multiplied by 3 over 2 t minus 2 sine of t and plus 1 over 4 sine over 2t with substitutions from 0 to 2p. So what about this sine of t and sine of 2t? They will be 0 if we substitute either 2p or 0. So what is interesting for us? Only the first addend. So 6 multiplied by 3 over 2 and multiplied by 2p. So the answer will be 18p. Any questions about this exercise?
No.
Okay, if no questions, let's move next. Okay, and here we have the following figure. So we have to calculate area of Bernoulli lemniscate, and the formula for parametric for curves in polar coordinates is the following. So 1 over 2 from 0 to, okay, it can be any, so alpha, beta, different values actually. So let's now write like this. A rho square from phi. So we need to integrate rho square. And actually that's what we have. Let's put this lemniscate. So a by square root of cosine 2 phi. Oh, yeah, it doesn't understand phi. Let's, yeah, theta in Desmos. So here is the lemniscate. And that's if we change A, what happens? So this figure is symmetric, and as we can see, so we have to integrate from from minus p over 4 to p over 4. If I put this so if I add a range of such values, so p over 4 and so minus p over 4 and p over 4. So because we have such rays that corresponds such angles, so it corresponds p over 4 and this for minus p over 4. So in this case, yeah, we actually can even integrate from 0 to p over 4 because of symmetry. So we will have to multiply it by 4. Uh, 1 over 2. Integral from 0 to p over 4. A square cosine over 2 phi d phi. And let's calculate this integral. So yeah, also let's move add-ons. So let's move coefficients out of brackets. So to a square. So just for our convenience. And then we have a square sine of 2 phi with substitutions from 0 to p over 4. So sine of p over 2 is 1, sine of 0 is 0, so the answer is a cube, a square. Any questions about this exercise? Yeah, so here is a mistake in this material, so I will have to correct it. So it must be it. Yeah, because I calculated initially incorrectly. So any questions about this exercise for now? Okay, if no questions, no questions, yeah?
Yes.
Okay, let's move to the next exercise. And now we will calculate the length of the curve. So, how to calculate it? It is calculated by the following formula. So if the function is given explicitly, so integral from a to b dl. So this is the differential of length of the curve, and how it's calculated for explicit function y from x, so 1 plus y prime in power of 2 dx. So in our case, let's first of all give this function implicitly, explicitly. So because we have y square equals x cube. First of all, let's plot it. Just to understand, so we have the following form curve. And if I plot, for example, square root of x cube, I have only this half of such a figure. So I don't remember this. So how it is called, but actually the one case of cubica or something like that. So and from x to corresponding values of x from 0 to 1. So sorry. So from 0 to 1 we have such segment. But it will be enough for us to calculate length of this segment and then just multiply by 2. So y will be equal square root of x cube. Then y prime will be equal 3 over 2 square roots from x. So dl will be equal, okay, let's write it here. So it will be equal 1 plus 9 over 4 x dx. So let's substitute this value into this integral. So we will have to calculate the following integral from 0 to 1 and this integrate this function by x. So y multiplied by 2 because we calculate only this segment, but this is symmetric, so we're to not calculate two integrals, analogical integrals. So here we'll use differential entry technique. So 2 multiplied by, stop what I was doing. So Control F. Yeah, 4 over 9, and here we'll have differential over this value of this expression. And now let's integrate. So 8 over 9 and what do we have here? Yeah, 8 over 9 by 2 over 3. And the following expression. From 0 to 1. So 16 over 27 and the following expressions. The following. So here, what do we have? 1 plus 9 over 4. By this. And here just, so we have substitute 0, just 1. So we have 16 over 27 and here, so yeah, so we have the following expression. So 13 over 4 by okay, by square root of 13 over 2 minus 1. So actually that's all what we can calculate here. So irrational result, and we will leave it like this. Any questions about this exercise?
How we get this antiderivative in the last part of in the first row?
Mm,
This, yes,
yeah.
2/3 and
Let me remind you. So x in power of alpha dx. So the integral is the following: 1 over alpha plus 1 and x in power of alpha plus 1. And
and
yeah, for this case, alpha was 1 over 2. So we increased and it is equal 3 over 2. And we divide by it. So that's why 2 over 3. So I answered your question, right?
yes, yes, thank you.
Okay, more questions about this exercise? Okay, if no questions, let's move next to the next exercise. So we need to find the length of the circle. Uh, so such a hard uh, such hard exercise. So yeah, interesting. What could be equal length of the circle? But yeah, let's calculate it. So uh, yeah, let me. So what is interesting for us? Just to calculate a length of the quarter of the circle, and I will plot the graph of the uh, semi-circle. So the semicircle that is located in the on the top, but what will be interesting for us only from only this quarter, and it will be multiplied by 4. So the explicit expression is the following. So y prime will be equal uh, so uh, 1 over to these expressions and multiplied by minus 2x. So it will be the following. So x here, yeah, and minus here will be. So the dl will be equal 1 plus 1 plus this expression in power over 2. So x square, and here the square root goes away. So dx. Now let's modify it. So what we will receive? So r minus x here, and here r minus x square plus x square dx. So as the final form of this differential, so square root of r minus x square and r, so dx. So that's the expression that we will have to integrate. So calculating the following integral. So from values from 0 to r. So because so we calculate from this center from beginning of coordinates, we calculate to the to this to the radius, but and the radius is so can be any number. And calculating these expressions, this expression, integrating this expression, yeah. So, first of all, let me move out any number coefficients. What we here can see, it is the table integral. The following integral will be, so 4r multiplied by arc sine over x over r. And with the substitutions from 0 to r. So arc sine over 1 is p over 2. Arc sine of 0 is 0. So surprisingly, the length of the circle is 2pr. Interesting, yeah. So that's so the formula that you know from the school. Okay. Any questions about this exercise?
No.
Okay, now let's move next. Now we have to find the length of the curve given in the polar coordinates. This is the cardioid. Let me also plot the graph of this curve. So this is the cardioid, and values of phi are from 0 to 2p, but it will be enough for us just to integrate from 0 to p and multiply by 2. So, how to calculate it? So we need to find, first of all, a differential of the length of the curve. So, for polar function will be a rho square plus a rho prime square d phi. So let's calculate let's calculate rho prime. So the derivative. So it will be equal a minus a sine over phi. And now let's calculate. So let's calculate this expression. So a square 1 plus cosine of phi square plus a square sine over phi. Sine square of phi, of course. So expanding these brackets. Yeah, let's also move a out of brackets. So 1 plus 2 cosine over phi plus cosine square of phi plus sine square of phi. So let's simplify this expression. So we will receive 2 plus 2 cosine of phi. And actually this 2 plus 2 cosine of phi will be equal for so for a square cosine square of p over 2. So if I substitute it here, I will receive 2a cosine square of phi over 2 d phi. So now let's integrate this expression. It's so now it's so easy. Remember that we multiply by 2 because we integrate from 0 to p. So okay, let me just copy and paste it. And first of all, I will move out all numbers. So for a, and now we have 2a sine over phi over 2 with the substitutions from 0 to p. So sine of p over 2 is 1, so the result is 2a. Any questions about this exercise?
Probably I mistaked. I think that cosine.
Sorry?
Um, I mistake. No.
So everything is correct for you, yeah? So no questions.
Yes. No
Okay.
questions.
Maybe more questions from anybody else? Okay, if no questions, let's move next. Let's solve one more exercise and we will have a break. So task number 7, we have to find the length of the asteroid. It is the following curve. So which coefficients do we have? 2. So 2 cosine over t. So, and damn it. So in power 3 and 2 sine over t power 3. Yeah, so I also need to use brackets here and here. So parameter t from 0 to 2p. But yeah, so we have to find the length of the whole asteroid. But what can we do? We can just integrate from 0 to p over 2 and then multiply by 4, as we did it before. So yeah, the formula of the differential of the curve length is so will be the following for parameter graph. So x square prime uh, plus y prime square. Yeah, and by the way, this of course, x and y depend on t, and dt. So this is the differential of the curve length. So if we had implicit function, so x would have been equal to 1, then we have then y in implicit form we have not implicit, explicit. So 1 plus y prime square. So here is the following formula. So let's calculate x prime. So it is equal 6, yeah, or actually minus 6 cosine uh, square t by sine of t. For y prime, so 6 by sine square of t by cosine of t. And let's calculate this expression. So what do we have? 36 cosine of t in power of 4 by sine square of t plus 36 sine of t in power of 4 by cosine square of t. So now let's move 36 sine square of t by cosine square of t out of brackets. And what we will have, so in this case, cosine square of t plus sine square of t. So the result will be the following: 36 sine square of t by cosine square of t. So now it's substituted under the square root. So dt, and what we have 6 sine of t cosine of t dt. As we can even write it, so we can simplify it, so it will be 3 sine of 2t dt. And now let's integrate. So L will be equal 4 integrals from 0 to p over 2, and this expression. So 12 integrals from sine of 2t. So minus 6 cosine over 2t, and from 0 to p over 2. So minus 6 multiplied by 0 minus 1. So the result is 6. Any questions about this exercise? So no questions,
No
right?
question.
Okay, if no questions, let's go for a break, and then we will calculate, we will use integrals for calculation of volumes, mass, and moment of inertia. And now let's have a break for 5 minutes. Okay, let's continue. So now we will calculate volumes. Uh, okay, so task number 8. That's so laggy for me. So task number 8. We need to find the volume of the body formed by the rotation of a plane figure bounded by the following lines. So let's draw it. Let's draw this graph. So x y equals 1, then x equals 1, so x equals 4, and y equals 0. So we have to calculate uh, xy equals 4. So we need to calculate area. Not the area. So we have the following plane figure. This one that is bounded by these curves, and it is rotated around. Uh, Let me check y or x axis. So around the x axis. So the formula of the volume will be the following. P multiplied by so from A to B, f from x f square from x dx. Because the axis of rotation is x, we integrate by x. If the axis of rotation would be y, we would have rotated by y, or integrated by y. So the following, so let's write also function y explicitly. So y equals 4. It is the same as x. So as y equals 4 over x. And bounds of integration are 1 and 4. So we integrate from 1 to 4. The following expression. So 16 over x square dx. No, dx is not in the denominator. Yeah, we can integrate it. So minus 16 p 1 over x with the substitutions from 1 to 4. What's going on? Yeah, something about with hotkeys. So 1 over 4 minus 1. So it is minus 16 p by minus by minus 3 over 4. So it equals 12 p. Any questions about this exercise?
No.
Okay, no questions, so let's move next. So we have the following exercise. So exercise 9, we need to calculate the volume of the part of the paraboloid formed by rotating the arc of a parabola y equals x squared around y-axis. So let's plot it. So y equals x squared. Yeah, so different hotkeys for math type and for Desmos. And so y equals x square, and here I will specify the values. So x from 0 to 2. So we need to calculate, so we take the following segment. Why it's not working? Oh no, something went wrong. Ah, this. So let's draw. So we have this figure, plane figure, and rotated by axis of so by y-axis. Okay. And now let me clear it. So x equals square root of y. So we need to write explicitly this function. So now x depends on y. So and the formula of the volume is the following. So from 0 to p, from 0 to 2, and yeah, stop. Just a moment. What is interesting for us in such case? So we need to specify a range of y values. So from 0 to 4, because y equals 4 on the top bound. And integrand is y dy. So now let's integrate. So 2p by 1 over 2 y square from with the substitutions from uh, 0 to 4. So what we have 16p. This is the final answer. Any questions about this exercise?
I don't understand why the integrand is y, but not a square root of y.
Because okay, let me write it in. Oh, stop, not 2p. First of all, it was a mistake here. So if we rotate, yeah, so we rotate around y-axis, so f from y, and so square of f square of y. So because we calculate volume of rotation body, so f from y equals the square root of y, so f square equals y. Have I answered your question?
Yes, thank you.
Okay. More questions? Okay, if no questions, so let's move next. So now we have so the following exercise about a cardioid. Let me remind you how does cardioid look like. So R equals A multiplied by 1 plus cosine over theta. And we need to calculate volume of the plane figure. So we rotate cardioid around the polar axis. What is interesting for us, so only this top half. So if we specify from 0 to p, the formula is the following for polar coordinates. So we integrate rho cube from phi and from alpha to beta. Yeah, and d phi, of course. So in our case, 4 over uh, uh, 4 over 3p, and we integrate from 0 to p, and 1 plus cosine, yeah, a cube. 1 plus cosine of phi d phi. And let's rewrite this expression. Yeah, let's expand
But
these brackets. Sorry?
I have a question, but we also need to multiply this expression by 2 because it's in
Yes, thank
half.
you for your attention. Yeah. Mm. Yes. And now let's expand brackets for this expression and modify it for better integration. So 1 plus cosine phi in power 3. So 1 plus 3 cosine of phi plus 3 cosine square of phi plus cosine cube from phi. So let's modify it. So actually what is interesting for us, so we will change, so we will reduce degree for this expression. So plus 3 over 2 plus 3 over 2 cosine of 2 phi. Now let's add 1 plus 3 over 2. So 5 over 2, moving here to the beginning. And now let's integrate this. So let's calculate this integral just so separately, integrate these expressions. So I1 equals, so from 0 to p 5 over 2 d phi. So it will be equal 5 over 2p. Then I2 equals, so we will integrate 3 cosines of phi, and so we have 3 sines of phi with the substitutions from 0 to p, and it will be equal 0. Then I3. So we will integrate 3 over 2 cosine of 2 phi. And we will receive so 3 over 4 sine of 2 phi with substitutions from 0 to p. And of course it will be equal to 0 as well. Then I4 equals so integral, so we will integrate cube, cosine cube of p d phi. Let's modify it a little bit. So we'll remember some kind of practice. So 1 minus sine square over phi multiplied by cosine of phi, and basically this is so cosine of phi d phi is the differential of sine of phi. So from 0 to p sine of phi minus 1 over 3 sine cube of phi. And if I substitute again p and 0, we will receive 0. So finally, what do we have? So 8 over 3 pa cube, and multiplied by I1 plus I2 plus I3 plus I4. And so we have this 8 over 3 pa cube multiplied by 5 over 2 p. So final answer will be 10 over 3 stop, not 10, but 20 over 3. 20 over 3 p square a cube. Any questions about this exercise? Okay, as I see, no questions. Now let's move to let's solve exercise 11. I will not erase these integrals because they will be similar to integrals that in exercise 10. And what we will have to calculate, so we will have to find the volume of the solid revolution obtained by rotating one arc of cycloid around its base. So let me again plot the cycloid t minus sine of t and a by 1 minus cosine of t. And p is from 0 to 2p. And yeah, we can vary value of p, so using by this slider. Oh, not p, but we can vary value of a, and we can see that cycloid is modified. So base of cycloid is x-axis, so we will rotate around x-axis. So how to calculate it? So from A to B, and of course we'll multiply by P. So not 2P, but only P. So Y prime, oh no, not prime, Y square from T by X prime T dt. So actually, yeah, so dx equals x prime from t dt. Okay, so x prime equals x prime from t equals a by 1 minus cosine of t. And what we actually received here. So we have here we will have a cube by 1 minus cosine of t dt. So 1 minus cosine t cube dt. And we integrate from 0 to 2p. So we have similar integrals, but different signs in some places. So yeah, let me rewrite this expression. So 1 minus cosine of t cube equals 1 minus cosine of t plus 1 minus 3 cosine of t plus 3 cosine of t square plus cosine cube t. Minus cosine cube t. Sorry. So what do we do here? Yeah, also let we rewrite it a little bit. So 1, yeah, so we have 3 over 2 here again. So 3 over 2 cosine of 3 over 2 plus 3 over 2 cosine of 2t. So we have similar integrals. 5 over 2. So 5 over 2, but actually dt. So we have here 5p for this integral. Then minus, so integral from 0 to p cosine of t dt. So here we have minus, but actually 0. So integral, so I3, what does equal? So 3 over 2 cosine over 2t dt. And again, 0. So just everything is analogical. That's why I didn't want to erase this calculations. And again, I1 plus I2 plus I3 plus I4. And what do we have? So we multiply by 5p. So 5 p square a cube. Any questions about this exercise?
Could you scroll down where I1, I2, I3, and I4? No questions.
Yeah, so zeros everywhere when we have where we have trigonometric functions. Maybe more questions. Okay,
No.
so with no questions, let's move to the final exercise. It is about so I'm not sure that we will have time to calculate everything, but so let's so we have the arc of circle. So 3 minus x square. Oh, so 9 and minus, so square root of 9 minus x square. So the following. And we have to calculate the mass of the figure, static moments, and moments of inertia with respect to x and y axis. And then we have to find coordinates of the center of mass. A linear density is a constant. So first of all, let's calculate mass because it's easier. So it is calculated by the following formula. So from A to B, mu from x dx. And in this case, so we integrate from 0 to 3, yeah, and let's multiply by 2 from 0 to 3 because of radius 3, and we only for this part calculate and then multiply by 2. So mu 0 dx. So actually this it will be equal 6 mu 0. So found it. Y3. X from 0 to 3. So we even calculate only for the quarter of the circle. So we don't multiply by 2. So my bad. And now everything is okay. Then we have to find, okay, let me comment here. So we have to find static moments. Static moments are found by the following formula. So a relative x-axis, we calculate it with using the following formula. So, okay, let me also just check myself if everything is correct. Yeah, so calculations are correct. So 1/2 following integrals. So from a to b and y dl. And for x, vice versa. So with respect to y-axis, everything is vice versa. So here, so here is dl, so found it. And we just substitute this expression, this square root, instead of y. And for my, we just substitute x. And yeah, this integral is, oh no, the first integral is easier to calculate, but anyway, all of them can be calculated. Then, calculating moment of inertia. So the following formulas. So if we calculate with the respect to x-axis, we have the following integral. So from a to b, x, oh no, 1/3. And by the way, we don't have to multiply by 1/2 here. It is a mistake. So 1/3 and y cube dx. So this is the moment of inertia for x-axis. And for y, yeah, it seems that something is, no, everything is correct because, so y cube, yeah. Oh no. So yeah, it has to be recalculated after that. So moment of inertia for y-axis is the following formula. So from a to b, x square y dx. And yeah, here, so either this formula or we can use another formula. So from a to b, x square dl. So either this or this formula, and will be the same result. So here we use trigonometric substitutions to calculate. Then coordinates of the center of the mass. So the following formulas. So for so we find for this curve, so x center, so it's calculated by this formula. So we divide by the integral. So we divide integral by the length of the curve. So a so x dl. So like this. And for y analogically, but we swap y with x. Just a moment, we'll be a little bit away for 1 minute. Okay, so the formula is for y coordinate of the mass center is the following. So we divide by, so again, analogically to x. So, okay, let me check y2 over p. So the length of the curve is 2pr. And if we divide by, okay, yeah, so okay, 1 over L equals 1 over 3 So we have 1 over 2 p, because the quarter of yeah, and r is 3. So that's why 2 goes to the to the numerator, but it's a question why 3 is in the numerator as well. It must be in the denominator, so need to correct it. And now, any questions about this exercise? About the whole lesson, previous lessons?
For now, not. But they can appear.
Anytime, so feel free to text me in Google Chat. Of course, you can write in Gmail, but Google Chat is preferred. So for now, we are finishing our lesson. Have a nice day. Stay safe. Thank you for your attention. Goodbye.
Thank you. Goodbye.
Thank you. Goodbye.
Thanks for the lesson.
Bye.
Have a nice day too. Goodbye.
Thanks.